And now I will start to teach for the ridge body diagram for this first. And I will have the screen recorded. And the first 4.2 is need to know determine the reaction at the sports. So we have the rigid body for it AB, and here is the area, and I have to cut for it to two area for this square and this triangle. Okay, and if we need to know the total force, we have to calculate for the area for this square and this triangle's area, and we have to know this 600 is here, and here's the 6 is the 3 meter plus 3 meters, and this is 6 meters, and here's the triangle's area is like this, and we have to know the total force. And the questions asks the reaction support at the support is the direction with the x axis, because yes, this y and x is x axis, and we have to know this is the squares force, and we have to we have the squares, we have in the half, we have to know this is the 3 meters, and here is the triangle's areas force, and here we have the 1/3, and we have to know the answer. And we have to know the fx equals 0, so bx is 0, and fy have 0, the by and ay have the O force at f. This is fr's force, so we have to know here with the moment we can know the ay with the ay with the 6 meters plus here all the forces is 4050, so the ay we can know the answer is 2175. And the next question is 4.5, and also I have to open the screen record. And the question asks determine the component of the support reactions at the fixed support A only cantilever beam. And here I have the line with the this 4 kilogram newtons force with this in the x and y directions. And first I have to write down with the fy equal to 0, and here is the ay, and I cement it is upside, so this is the positive, and here the 6 kilonewton have to with the down direction, so it is minus, and minus for here 4 kilogram with the sine 30 angle, so we have to know the ay is 8 kilonewton. And the next step is by the summation of f of x, and with the ridge body summation of f of x is equal to 0, so we have to know the ax plus here 4 times cosine 30 angles with 0, so we can know the ax answer. And we need to know the moment with the moment A here, because the question asks reaction at a fixed support A, so we have to know the moment 8, and the total moment 8 with the equal to 0, so with the 8.6 have the 1.5 meters distance, and here have the cosine, here the distance with the here, because I have plus 35 and like this. So we have to know the answers. And here with the 4 sign, because here's the distance. So we have to know the moment of A is 20.2 newtons. Okay, the next question is 4.22, and here is the screen recorded. Okay. And the questions asked: determine the horizontal and vertical components of reaction at the pin C and the force in strut AB. Pin C here and the AB. And for the list rigid body diagram, we have to know the AB. For this, we have the force like this here, and we can know the force AB need to have the this y, and we can know for the C here's with the total squares, we can do better to know how we can know the O force. And for this force, we can know the angle for the here to the C is the 20, and here is 30. So we can know here AB triangle here is 40, and here is 50 angle. So for the first, we can to calculate for the force of X axis, and total for the rigid body f of x is total for the 0, so we can to know the f of b with sine for here's sine 50 here, and cx with cs here. We can know cy and cx because this is just for the pin C, and cx and 2 for the here. And the next, we can know the force of y, and the same with the FAB with angle 50 with here, and the CY, and here the 6 kilonewton. And we have to know, don't know the FAB, FC, CX, and CY, so we have to calculate for the moment of C here. And moment of C, we can have to know the FAB for the cosine 50 here, and with the 0.4 and tangent 20 here. Tangent 20 is because the list with this triangle, for this triangle, we have to know the angle for the 20 for the tangent 20 with the BC over 0.4. Here is the 0.4 with the BC. So the BC is 0.4 times tangent 20. So here is the BC, and because the direction for the f of b, because this is counterclockwise, so this is minus, and FAB sine 50 and 0.4 and plus, like here 2 plus 1, here is the 1 meters, and here 6 here with this distance for the 1 times tangent 20. So we have to know the total with the FAB, so, and we turn in here so we can know the CY and CX, and we have to know the answers. And the next is for the 4.38, and we have the screen recorded and started. And the question asks: the shaft is supported by this smooth journal bearings at A, B, and C. Determine the components of reaction at these bearings. So here is my answers. So we have to know the first things with the rigid body for the f of x. We have to know, I have to draw the AX, AZ, and BZ, BX. and cy with the cz. So we have to know to start it for calculate for it. And the summation of f of x here is ax plus bx and minus 500, because here is the direction for minus. And the next f of y with the cy, because the c is on the y-axis, so the c points didn't have the cx directions, and the cy minus here's minus 450, and we have to know the cy. We have the one answers, and the f of z axis we have to write down for like this, for az and the minus of 600, and bz, and here minus 900, and here is a cz is have a many forces, and we have to list all of force, but we don't have know the all answer, so we have to write down the moment of x, moment of y, and moment of the z. We can know the all answers with the every spot's forces. And here the az minus 600 plus bz, for the moment of x here is this here, and times for the 0.9 meters, and the next with the, and because this is minus, because this is counterclockwise like this, so this is minus, and here bz times 1.8 because here, and bz here, and this is positive, and the same with this 400 and 0.6, and here directions, and cz for the here to the axis direction, so it's 2.7, and luckily we have to know with the bz with 1125 newtons, and the next with summation of moment of y-axis have to know with the 600 here, and the y-axis like there is the 0.6 meters, and the next with the cz with here like to the y-axis direction, so here, and the next 900 with the directions with the y here, the 0.59 meters. So we have to know the cz luckily, and the next is the total moment of the z-axis, and the z-axis is here is 500, and here 0.9 with the direction to the z-axis, the distance to the z-axis, and the bx here to here, so this is 1.8, and here, so we have to know the directions 0.9 meters and the cy's, and we have to know here the direction here, so we have to know the bx, and we have to write down the answer. This is the total forces.